Welcome to this installment of the Microchip Technology Self-Paced Training. In this self-paced training, I'll cover the Configurable Logic Cell. I'm your host, Chuck Hellebuck. In this training class, I'll cover the CLC structure, input data section, data gating section, logic function section, output control, a CLC Setup sample, the CLC Design Tool, and a summary with additional resources. At the end of each section are questions to test your knowledge. Let's start with the Configurable Logic Cell structure. The Configurable Logic Cell, or CLC, provides programmable digital logic within the microcontroller that operates in parallel to any software operations. The logic cell multiplexes up to 16 different input signals through configurable logic gates into a single logical output. A PIC device can have multiple cells in one package that can be cascaded to make various logical operations, all independent of software timing limitations. The CLC includes the following features. The CLC offers digital logic control that runs outside the limitations of software. Input options include up to 16 different choices. Inputs can include various device peripherals, including I/O pins, timers, and even outputs from other CLC modules. This allows CLC modules to be cascaded. There are 8 different single output logic functions to choose from. A CLC output can drive an I/O pin or trigger an interrupt, or do both. Depending on the size of the device, a PIC MCU can have multiple separate CLC modules. The Configurable Logic Cell has 4 main sections: inputs, data gating, logic functions, and output. Inputs can come from 16 different sources. These 16 inputs are multiplexed down to 4 signals that feed the data gating section. The logic functions include 8 prearranged logical options. All this gets sorted down to one logical output. That output is then sent to an I/O pin, another CLC, or can trigger an interrupt. There are 4 stages to setting up the Configurable Logic Cell. They include the input data selection, the data gating selection, logic function selection, and output control. This is controlled by 8 registers inside the PIC MCU device. In this training, I'll show you how to set up the CLC module using these 8 registers. Then we'll introduce a graphical tool that makes it even easier to set up the CLC module. Let's look at the input data section. The input data section is controlled by 2 registers, the CLC Select 0 and the CLC Select 1 register. There are 2 select registers for each CLC module. The inputs for the CLC module can come from I/O pins, internal clock sources, various peripherals within the device, and various register flags. The inputs get multiplexed down to 4 signals that get passed on to the next section of the CLC module. The Configurable Logic Cell has a selection of 8 or 16 different inputs to choose from, depending on the device used. The example list shown here is for the PIC 16F150X device. Each input source has a 3-digit code associated with it. The inputs are grouped in blocks of 8. Each multiplexer has 8 inputs to choose from, and each input source can be connected to 2 separate multiplexers. This allows just about any combination of 4 inputs to be selected. The 3-digit codes are input into the CLC select registers to choose the 4 inputs that will be passed on to the data gating section of the CLC module. This example shows the input codes placed in the CLC select registers. The data gating section is the next area to set up. The data gating section is controlled by 5 registers. There are 4 gate logic registers for each CLC module. The CLC Polarity register also has some control over this section. The data gating section starts with a base set of OR gates that can be modified to create other logic cells. They become a pre-filter to the logic function section. Each input to a data gate can be individually inverted or not inverted. The output can also be inverted or not inverted. This allows these gates to be converted to act as other types of digital gates. The setting of bits within the CLC GLS0 register and the CLC POL register control the gate selection. Using the inverting input and output options, these gates can be created. An AND gate, a NAND gate, a NOR gate, and an OR gate can be created. The gate can also be set to output a constant logic 0 or logic 1. To set up a NAND gate for data gate 1, the CLC1 GLS0 register is set to 55 hex, and the LC1 G1 POL bit in the CLC1 POL register is cleared. The table shows other register settings to create the other logic gates. The gates' inputs are controlled by 2 bits each. Setting the T bit makes the input a direct connection. Setting the N bit makes the input inverted. The output is inverted by setting the LC1 G1 POL bit to a 1. Both the T and N bits can be cleared to 0, and then the polarity bit can control the logic level of the output. Setting both the T and N bits to a 1 is not recommended and may emit logic glitches. The logic functions are the next section. The logic functions are controlled by the CLC control register. The logic functions section has 8 options to choose from: an AND/OR combination, an OR exclusive OR combination, a 4-input AND gate, an SR latch, a 1-input D flip-flop, a 2-input D flip-flop, a JK flip-flop, and an input latch. Each different combination has a 3-digit code to select the logic function within the CLC control register. Here we have 4 of the choices and the 3-digit code for each choice. The remaining 4 options are shown here. These 3-digit codes are placed in the CLC control register LC mode bits 0 through 2 to select one of these combinations. Here we have an example of selecting the JK flip-flop with reset for the logic function. The 3-digit 110 setting in the LC mode bits of the CLC control register locks in this selection. Now we'll set up the final stage that controls the output of the CLC module. The CLC output has several options for setup. The CLC control register and the CLC polarity register control the setup of the output signal. All the CLC inputs, gating, and logic functions reduce the result down to a single output that can drive an I/O pin, feed another CLC module or internal peripheral, and also has the option to create a rising edge or falling edge interrupt. The output signal is controlled by the CLC control register. The polarity of the output, as well as the interrupt signal, can be controlled by bit settings in the CLC control register. The CLC output can also be disabled at any time by the CLC enable bit in the CLC control register. The output pin can drive a physical I/O pin with a single bit setting in the CLC control register. The polarity of the CLC output that feeds the output section can be inverted by a bit setting in the CLC polarity register. A 1 inverts the output and a 0 is not inverted. The specific bits in the CLC control register that control the output operation are shown here. The LC enable bit can enable or disable the CLC module. The LC output enable bit can enable or disable the output signal. The LC out bit is a read-only bit that can be monitored in software to check the status of the CLC output state. The P bit enables a rising edge interrupt, and the N bit enables a falling edge interrupt. Let's bring all this together into one example. This example shows a setup for the CLC1 module. The 8 registers are shown in a format that would be included in a Microchip XC8 compiler software file. 4 inputs are routed through the OR gates and then into an XOR combination. The output is non-inverted and is connected to an I/O pin. The CLC Design Tool can make it much easier to set up a CLC module. The CLC Design Tool uses a graphical user interface to easily set up the CLC module. The tool outputs code for either C language or assembly language. The first step is to select the device that will be used. This will enable the proper settings within the tool for that device. Four drop-down menus allow you to select the inputs to the CLC module. The data gating connections are set by simply clicking on the X next to the OR gate. Each click changes the connection. It goes through three states: no connection, direct connection, inverted connection, and then back to no connection. Clicking on the output of the OR gate will invert or not invert the output. Logic functions are selected by clicking on one of 8 tabs. The graphics will change to show the setup selected. The output settings are selected by a checkbox or multiple boxes in the lower right-hand corner of the screen. The results of all the settings are shown for the 8 registers that control the CLC module in the upper right-hand corner of the screen. The File menu at the top allows you to output the setup as a C language or assembly language insert. It creates an include file that you save to your hard drive. Then you can use a #include to add this setup to your software program. Here are a few application examples to show where the CLC module might be used. A pair of CLCs may be combined to implement more complex logic functions, such as a data modulator. The example shown here is a phase-shifted data modulator using the CLC module. As shown in this example, the output of one CLC module may be used as an input to another CLC module. This example shows how easy the CLC can be used to create a Manchester encoded output. In this example, the SPI peripheral is an input to the CLC module. Another potential application for the CLC is output pin rerouting. In this example, the RB7 EUSART transmit pin can be rerouted internally via the CLC to output on RC4, RC0, RA4, or RA2 pins, thus saving the additional board space to run additional traces or perhaps eliminate the need for an additional board layer. Used in this manner, the CLC could save both board space and cost. Now I'll summarize this CLC training. The CLC runs in parallel to software. You can get multiple modules in one PIC device. Sometimes external hardware functions can be incorporated into the PIC device. The CLC module has 4 basic sections. 8 registers are set up to control a CLC module. The CLC Logic Tool is a software GUI that makes setting up the CLC module much easier. The CLC Logic Tool outputs a C or assembly language insert for the PIC device's software. There are additional resources available for the CLC module. There are several different documents to help you use the CLC module. You can download any of the documents at www.microchip.com/CLC. Datasheets for the devices contain information on the CLC module. Listed here are just a few. CLC design guides are also available. A couple CLC application notes for glitch-free design and delay block debouncer are listed. This completes the CLC training module. I hope you found this training beneficial, and I thank you for watching.